All right, looks good. Okay, so today is all about special parallelograms. Blue today. (5-4) special parallelograms. Okay, I need to make it abundantly clear that all of the ones that we're going to talk about today are types of parallelograms. So all of the things that we know are true about parallelograms are true about these other shapes also, because they're all types of parallelograms. So the things that we know about parallelograms, they have two pairs of opposite sides that are parallel, two pairs of opposite sides that are congruent, diagonals that bisect each other, opposite angles are congruent, consecutive angles are supplementary. Remember all those fun facts? They still hold true for these. So big star, all of these shapes are parallelograms. So everything true about parallelogram is true for them too. I'll even make that list. So opposite sides parallel, opposite sides congruent, opposite angles congruent, consecutive angles, supplementary, and diagonals bisect each other. Okay, so all of these shapes get these facts as well. I'm gonna shuffle it up. Okay, so our first shape that is a special type of parallelogram is our friend the rectangle. I asked you, what makes a rectangle a rectangle? Aiden?
Has two sets of parallel lines and more than
That's it. So it's a type of parallelogram with 4 90-degree angles. That's all you need to be a rectangle. Give me 4 90-degree angles inside a quadrilateral and boom, you have a rectangle. Okay, so it automatically inherits all of these fun facts. It does have opposite sides parallel, congruent. Opposite angles are congruent. Consecutive angles are supplementary, and the diagonals do bisect each other as well. Now, a rectangle has its own fun fact. Something that only applies to rectangles and not other parallelograms. And it has to do with the diagonals. Anybody care to guess what it is? What is true about the diagonals in a rectangle that's not true in just a regular old parallelogram? Both will have diagonals that bisect each other. That will always be true. That works for any parallelogram. Carson?
Wait, okay.
Anybody have a guess about the diagonals in a rectangle? I'm going to draw it.
I think
They are. So here is my rectangle, 4 90-degree angles. If you draw in the two diagonals in a rectangle, not only will they bisect each other, because we know that that's true in any parallelogram, they will be equal in length. That is not true for anybody else besides a rectangle. Okay, so rectangles, fun fact. How should I say this? I want to, yeah, I'll go with this. Fun fact for rectangles only. Diagonals are equal. So in my diagram, that means all of AC is congruent to all of BD. Now, I know what some of you may be thinking, but Mrs. Savia, isn't that true in a square too? Wouldn't a square have diagonals that are equal to each other? Well, you're right. But you said that it's only for rectangles. Why am I not wrong? Carson. A square is a rectangle. Look at the definition of rectangle. It just has to have 4 90-degree angles. That means squares fit this definition, right? So a square is a rectangle. Is a rectangle a square?
No.
Not necessarily. It can be. So wait till you get to do the sometimes always nevers on this section. This is a doozy. Can a rectangle be a square? Sure, if it happens to have, what does a square have that a non-square rectangle? Exactly. So the square has to have not only 90-degree angles, but it also has to have the 4 equal sides. We'll talk about the square more in a minute. But for rectangle, that's the definition, and that's its fun fact. Okay, the next one we're going to talk about, we'll come back to square in a minute. The other one is our friend, the rhombus. What makes a rhombus a rhombus? Anybody know that one? What makes a rhombus a rhombus? That's what you have to have. So it still is a type of parallelogram. So it still has all of the fun facts that parallelograms have. Still has opposite sides parallel, opposite angles the same, all that stuff. But it has to have 4 congruent sides. That's the key for a rhombus. So let me try and draw one. Now, yeah, Carson.
So based on that definition, wouldn't a square also be a rhombus?
You got it. A square is also a rhombus, which is crazy. So a rhombus has some fun facts exclusive to the rhombus. Fun facts for the rhombus. go. That's better. All right, so besides having 4 congruent sides, fun facts for the rhombus. Let's talk about their diagonals. Do you think that they're equal in length? If I draw in the diagonal from A to C and the diagonal from B to D, do you think those are equal in length? No, they're definitely not. I have one that's significantly longer than the other. They will still bisect each other because that's true in every parallelogram. So I would know if I gave a letter in the middle, let's say that's E. I would know that AE and EC are the same, BE and ED are the same. Okay, fine. It's only the rectangle that gets all 4 little pieces, right? Because if the whole thing's the same, then all 4 little parts would be. So that's kind of cool. All right, but the rhombus doesn't have that. There is something that is true about the diagonals in a rhombus, though. They're not equal.
They can never
They can if your rhombus happens to be a square. Yeah. But here's something that's kind of neat, and you've actually proven this before. Look at these 2 triangles here, this one and this one. You can get those 2 triangles to be congruent relatively easily, knowing that we have a parallelogram, right? We would know they share the side down the middle, and these 2 are bisecting. So you could get those 2 triangles congruent by side, side, side. Pretty quickly, maybe some other ways too. So what does that mean about these 2 angles? Right there. If these 2 triangles, BEC and CED, if they have to be the same? Say it again?
Yes.
They are, yeah, they can be. You could prove it by side, side, side if you wanted. So these 2 angles right here, so angle 1 and angle 2. If those 2 triangles are the same, wouldn't those 2 angles have to be the same? And exactly, because don't they make a straight line together? So if they're 2 angles that are equal and they're making a straight line, they have to be 90s. So what does that mean? That means diagonals in a rhombus are always perpendicular. Always. Hi. Thank you. So that's his fun fact. Well, one of them. Diagonals are perpendicular. And another little tidbit about the diagonals, if these 2 angles are going to be the same, right? You could also tell me something about angles 3 and 4. What has to be true about angles 3 and 4? They're not 90, but they're also they're the same as each other, right? With CP. But you get those 2 little triangles congruent. They are corresponding parts of those 2 triangles.
Oh, I was looking at
Oh, yeah, over here. So these 2 have to be the same, which means, didn't that diagonal just bisect that angle in the rhombus? And couldn't I do this same thing for all of the other angles all the way around? So that's our second fun fact. Not only are the diagonals perpendicular to each other, they are also going to bisect the angles of the rhombus. How cool. Diagonals bisect the angles in the rhombus. And now, so that's it for the rhombus. Those are his own little claims to fame there. But now we talk about our friend, the square. So I do need to flip. The square encompasses all of these properties that we've talked about. It's still a parallelogram, so it still gets all the fun facts of parallelograms. But if you look at our definitions for rectangle and rhombus, a square fits both of those. A square is just a rectangle and rhombus put together. Yes, Eve.
So a square can always be a rhombus, but can a rhombus always be a square? Or is that only sometimes?
A rhombus is sometimes a square. Just like a rectangle is sometimes a square. But going the other way, a square is always a rectangle and a square is always a rhombus. So can a rhombus be a rectangle? Sometimes, if it happens to be a square. Yep, that's the only time. Ooh! All right, I gotta flip. All right, our friend the square. To define a square, it's so easy because you can literally just say it is a regular quadrilateral. Remembering what that term regular means, all sides the same, all angles the same. Yeah, that really does work. There's our friend the square. So big star for him. A square is a parallelogram, a rectangle, and a rhombus. So it has all of their properties. It doesn't have any unique ones to bring to the table. It just has everybody else's. Okay, we have 3 quick theorems and then we're done. Okay. So the first one says, if a parallelogram has a right angle, then it must be a you're not wrong, but you can go a little bit broader. It's got to be a rectangle. Yeah. If you just have one right angle in a parallelogram, they all have to be 90s, right? Because no opposite angles have to be the same and consecutive have to be supplementary. Cool. Okay, next one. If a parallelogram has 2 consecutive sides congruent, then it must be what you put in there. If a parallelogram has 2 consecutive sides congruent, it's got to be a person. No.
Oh.
Rhombus. So remember, opposite sides are the same. So if you have 2 in a row that are the same, you're going to get all 4 the same. And then the last one, we're going to talk about why this is tomorrow. This one's kind of wild. The midpoint of the hypotenuse of a right triangle is, so for now, I just want to fill this in and then we're going to kind of explore why this is tomorrow. Equidistant from the 3 vertices. And that's it. Okay, and then I think I have your homework here. Yeah, just this. We zoom in a bit.
I wasn't gonna write down.
Oh, sorry. Let me zoom out a little so you can see that too. Okay, and that's the homework right there. Can you guys read that? Page 187 and 188. Okay. All right, let me mark this down. Okay, so feel free to get started on that. I will open it up in Jupyter in just a minute. How are we doing? Hard at work, I see.